Hello, welcome to this video. Today we're going to look at this sum. So this sum is the sum as m goes from 0 to n of 1 over n plus 1 times n choose m. And your thought process when trying to evaluate the sum is probably trying to get this into 1 over n plus 1 into something with like x, something along the lines of x to the m, and then when you multiply it by n choose m, and when you sum that as m goes from 0 to n, you can use if you sum that as m goes from 0 to n, you can use the binomial theorem, which if you're not familiar with, I have a video about that explains everything about it, and this evaluates to 1 plus x to the n after expanding from the binomial theorem. But that is our goal, to achieve something like this. And 1 plus x to the n is much easier to work with than this ugly sum. And you might realize that integrating is the way of going about this, as the integral of x to the m dx is x to the m plus 1 over m plus 1 plus c. But if we evaluate this interval from 0 to 1, we need to evaluate this. This goes from 0 to 1, and it turns out to be exactly 1 over m plus 1. Meaning that we can replace our 1 over m plus 1 with the integral from 0 to 1 of x to the m dx. And so we can replace 1 over m plus 1 with, like I said, the integral from 0 to 1 of x to the m dx. So let's write that. The integral from 0 to 1 of x to the m dx times n choose m. Alright, now we can swap the integral and the sum because they're both finite and defined everywhere, and everything like that. So this is the integral from 0 to 1 of the sum as m goes from 0 to n of x to the m times n choose m dx. And I said that, by the binomial theorem, we earlier saw that this is just 1 plus x to the power of n. Again, if you aren't sure about why this is true, I have a video about that explaining n choose m, its properties, how to derive it, everything. So this is just the integral from 0 to 1 of 1 plus x to the n dx. Now this is just an integral of a linear function to the power of something, meaning that this is the linear part to the power of the original power plus 1. So this is 1 plus x to the power of n plus 1 divided by this power plus 1 and divided by, again, times the coefficient of x inside this in the linear term. In this case, the coefficient of x is 1. And then this goes as x goes from 0 to 1, and this is just 1 plus x to the n plus 1 over n plus 1. If we plug in 1, we get 2 to the n plus 1 over n plus 1. If we plug in 0, we get 1 over n plus 1. And then subtracting 1 from the other, we'll get 2 to the n plus 1 minus 1 over n plus 1. So just in case it was fast enough for you to catch, when we plug in x equals 1, we get 2 to the n plus 1 over n plus 1. That's this bit here. and we plug in 0, that's 1 over n plus 1. We get this bit here, and then it's 1 minus the other, and common denominator of n plus 1, we get this result. And that is just the solution to our sum. And although problem for you at home, use a similar trick to find the sum as n goes from 0 to n of negative 1 to the n over n plus 1 times n choose n. And if you want to just pause the video and try to work it out. Now, if you did work it out, you should have gotten 1 over n plus 1. So I'll write this as homework. But our main sum we just solved 2 to the n plus 1 minus 1 over n plus 1. And that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.